This will be the last section of Chapter 7. 7.8, we're going to do negative rational exponents. So the question is, how do you simplify expressions if we have negative exponents? We've already done this before, we just have not done it with fractions. So I'm going to take you through how to do that. And also, don't forget to have your table handy. We're going to be referencing this at some point. So make sure you have the exponent table. Okay, so whenever you have a negative exponent, see if you remember this, we're going to take the reciprocal of what is inside the parentheses, if there is one. Either way, we're going to take the reciprocal of what's inside. And then you're going to change the exponent to a positive number. So there's one property we learned a while ago where if you have a number, let's just use x. X to like the negative fifth power. To simplify this without a negative exponent, we said you're allowed to take this as a fraction, make it over 1, use the reciprocal, which means flip this around, and then it becomes a positive exponent. So this becomes 1 over x to the positive 5. So we're going to do the same thing here. It's just that we're going to have a fraction instead of just a number 5. So if you look at this first example to evaluate this, we have 16 over 625. So it's already a fraction. We don't have to make it over 1. And we have a negative 3/4. So what we're going to do is we're going to flip this around and change this exponent to a positive. So let's flip this around. We get 625 on top. We get 16 on the bottom. And now we have the exponent as a positive 3/4. This is for when you evaluate fractions with negative exponents. So now it's positive. We're going to do what we did in like the last section where 3/4 has to go to both numbers. So it becomes 625 to the 3/4 over 16 to the 3/4. And then I can use the table, or you can use your calculator and do 625 to the 3/4 power. It'll give you the same answer. I'm just going to use my table by separating this apart, making this a 1/4 first, and then to the third power. And this is going to be 16 to the 1/4 to the third. And then I'll just use the table to do the rest of it. So we're going to find 1/4 on the table. Here's 1/4. We're going to find 625 right here. Read across, that's 5. This is 5, that's the inside, to the third. The bottom, do the same thing. We're going to do 16 to the 1/4. So 1/4, 16 is here. Read across, it's 2. So then we have 2 to the third. Now you may already know these ones, or you can use the table. It's fine. 5 to the third power is 5 times 5 times 5. That's 125. And the bottom, we have 2 to the third, which would be 2 times 2 times 2 is 8. And that's your final answer. Sometimes they can be reduced, but in this case, you cannot reduce this at all. 125 over 8, you can get decimal, but we'll leave it as a fraction. And part B, this one is not a fraction, so we'll make it into a fraction. Put it over 1. And then I'm also going to put parentheses around this, why not? And so we're going to flip this around as a fraction to make this exponent positive. So it's going to be 1 over 256 raised to the 5/4. So the 5/4 will go to everything. Now, if we put 1 to the 5/4, I don't know if you noticed, but if you look at the table, anything that has a 1 in it, either you're doing 1/3, 1/2, 1/4, it always gets you back to a 1. So no matter what, the top answer will always stay a 1, no matter which way you're going on this table. So I'm not going to actually put it to the 1 to the 5/4. I'm just going to say that's 1. Because no matter what exponent you use, you're going to get 1. The bottom we actually have to do, though, so we'll put that to the 256. And that's to the 5/4. All right, I'm going to separate this out. I think for the most part, I can just use the table. 256 to the 1/4 raised to the 5th. All right, let's look at the table for that. So 1/4, find 256. Here it is. That's 4. And then we're going to raise that to the 5th power. So I'll write this out. It'd be 1 over 4 to the 5th. So we took care of the inside, Now we use the table to finish this off. 4 to the 5th is 1,024. 1,024. Oh, that's in the denominator, and then 1 is on top. There we go. So it's 1 over 1,024, which would be a very, very small decimal. That's how you do it with some numbers. Now we're going to actually incorporate how to solve some equations with a word problem. Example 2. For mammals, a typical relationship between body weight, W, in kilograms, and resting heart rate, R, in beats per minute, is modeled by R equals 241 W to the negative 1/4 power. So here's our equation. So let's kind of recap. W is the weight in kilograms. Okay, so we need weight, body weight of something in kilograms. And the resting heart rate, it's in beats per minute. So R is your resting heart rate. So let's make sure we have those two variables figured out. All right, now on part A. Use this formula to estimate a 180-pound person's heart rate, resting heart rate, in beats per minute. And we also have this conversion here where we have to go from 1 kilogram, and that equals 2.2 pounds. So if you notice in the example, it says this weight has to be in kilograms. So when we put W here, it has to be in kilograms. But we actually have 180 pounds, not kilograms. So that's why we have to use this little hint here. So we're first going to change pounds into kilograms. So I'm going to use this 180 pounds. And since it's 2.2 pounds for 1 kilogram, hopefully you know how to do this. To convert it, we are going to divide it by 2.2. 2.2 pounds. And that will give you how many kilograms we have, kg. So use your calculator and divide. 180 divided by 2.2. I got 81. And we'll round this. It says 0.81, so I'm going to do 0.8. 81.8. It's a pretty long decimal because it keeps going. So this is going to be our W value. We just found the weight in kilograms. That's what it wants up here. And then the question is, well, what's the resting heart rate? So we don't know R. So we're going to plug in W and figure out what R is. It's actually not that bad. So we put R equals 241 comes down. The W is what we just found, 81.8. You don't have to put in kilograms here. We know that's the unit. And this is going to be raised to the negative 1/4 power. So if you're using a calculator, we're just going to do that all together. You can put this in all at once, or you can do it step by step. But remember, PEMDAS says you have to do exponents first, so the calculator will do all this work for you. You're going to do 81.8 and raise it to the negative 1/4. I'm wondering if I can do that on my phone here. I probably can. 81.8. That's being raised to the negative 1 divided by 4. Okay, hope this is right on my phone, and that would be 0.3325. I'm going to put a couple decimals there. And then we're going to multiply that by 241. All right, so 0.3325 times 241, get about 80, 80.1. So the heart rate would be close to 80, or you could say 80.1, and this is in beats per minute. I'll say beats per minute. So 180-pound person's resting heart rate, which there could be a number of factors that would change that resting heart rate for somebody, depending on your health, is about 80 beats per minute. If you're more active, it's probably a little lower. Okay, let's go down to a dog. If a dog's heart rate is 101 beats per minute, so now they're giving us the R value, 101. Estimate its weight in kilograms, and we're also going to do pounds. So our answer will actually give us in kilograms for the W, but we'll also change this to pounds. So we're going to find the weight, W in kilograms, and we'll change it to pounds. Okay, so we're going to use the same formula we had, but now we have R, so it's going to go 101 equals 241 times W, we don't know, to the negative 1/4 power. So we're going to solve this equation for W. So what do we do first? First, we're going to get rid of this 241. Since there's multiplication here, we're going to divide 241. So if we do 101 divided by 241, we get 0.41908, whatever. I'm going to round this to 0.42. 0.42. Round it up. And those cancel out. We get W to the negative 1/4 power. So we did this in the last section of how to solve this. The only difference now is that we have a negative number. The only way to get rid of this to make it no negative at all is to use a negative as well. So what I mean by that is we're going to do the reciprocal power here, 4/1, but we're also going to include a negative. Now, why would I do that? Well, because if you multiply these two together, it ends up being positive because you have two negatives being multiplied together, you get positive. And they're going to cancel out. So on this side, we're going to do the same thing. It's going to be negative 4/1. So we'll put this part in the calculator. These will cancel out because you'll get a positive 4/4. It's gone. So we're going to get our weight. This will be in kilograms. So let's see if we can do that. 0.42 to the negative 4/1. So that's 32.14. And this is in kilograms because that's what we found for the W. Now, if we wanted to also get this answer in pounds, which makes a little bit more sense to us because we don't really see things as kilograms too often, the pounds would be, okay, we have 1 kilogram equals 2.2 pounds. So we're going to have to do multiplication. We're going to take the 32, so in pounds, we're going to take 32.14 kilograms, and we're going to multiply that by 2.2 pounds for 1 kilogram. So what actually happens is the kilograms go away, and we can multiply it out. That's 2.2. So let's see what it would be. We have 32.14 times 2.2. So it's about a 70-pound dog, 70.7 pounds, with a heart rate of 101. A couple more examples, then we'll be done here. Another word problem using a negative exponent, as you can see. Example 3, if you have a savings goal of G dollars, okay, so you say you want like $20,000, all right, but you already have saved S dollars, okay, then there's a formula that relates the S and the G to an annual percentage yield R needed over time T in years to reach the savings goal is this. So S is how many dollars you have saved, G is your goal, R is going to be your percentage yield or your rate. Think of that as rate. And T is time in years. Right? It's right there. All this is raised to the negative T. And we'll deal with that when we get there. All right, so suppose Bruce has 50,000, so he currently has 50,000. So what would that go in for? How much he has saved. This is going to be S. And he wants to have 150,000, so he hopes to have that for his child's college education. So this would be how much his goal would be, G. So he wants to go from 50 to 150,000. And he wants to do that within 12 and a half years. So maybe he has, a 6-year-old kid and says in, 12 and a half years, I want to have enough money in his college fund to send him to college. So we're going to use this as will be our T value, 12 and a half. We're going to find the interest rate. So we're going to try to find R that he needs to get so that way he gets his savings goal. So he wants to figure out what kind of percentage of a return does he need to get for this money to basically triple 50,000 to 150,000. Okay, so I'm going to plug in the numbers here. So 50,000 is S, so we do 50,000 equals, or G is 150. Then we have 1 plus R to the negative T. Now T is in years. So, I guess I could do 12.5. I don't really like this. Maybe I'll just do like a mixed number and do it that way. Or we could do 12.5. I guess it doesn't really matter, but I'll do a mixed number. If you remember how to do that, I'm going to multiply the 12 and 2 together, which gives you 24, and you add the 1. So this here is the same thing as 24 plus 1, 25 over 2. They call that a mixed number. So I'm going to use that in place for the number of years. So this is 25 over 2. Okay, now we're just going to unpack this whole thing. Our goal is to get r by itself. I'm not going to work with this just yet. I'm going to get rid of this 150. So since you have multiplication between these two things here, I'm going to divide by 150, 150,000 on both sides. And so I kind of already expressed that this is, we're trying to triple his money. So if you take 50,000 divided by 150,000, that's going to give you 1 over 3, or a third. If you got decimal, that would be 0.333 repeating. So that cancels this out. So we have 1 plus r to the negative, here we go, negative 25 over 2. So now we're going to get rid of this exponent. I'm going to put like a big set of brackets here. On both sides, we're going to raise this to the reciprocal power, which is 2 over 25. But we're also going to keep it negative. Again, we want them to cancel out just to give you a positive 1. Two negatives will multiply together, and it'll go away. Do the same thing over here. It's negative 2 over 25. And then these will cancel. These will cancel. Positive. We don't need the parentheses anymore. We just have 1 plus r. So here we actually have to do this part, and you can do this in the calculator if you want. I might be able to do some of it by hand, but at some point you have to do it in the calculator. So if I did this like next step by hand, I would say, oh, this is negative, so I could flip this fraction around to make it 3 over 1. And then raise that to the positive 2 over 25. But it's still not going to be doable in the chart or anything like that, so you'll have to do this in the calculator. So let's do that now. I'm going to raise 3 to the 2 over 25. So I got 1.091866 with this part here. I'll do 1.09. Let's round that up to a 2. I want to go out a couple decimal places just to see what our rate's going to be. And we still have 1 plus r. To get rid of this 1, pretty easy. Just subtract 1. So that goes away over here. We're going to get r equals, what's 1.092 minus 1? That gives you 0.092. And lastly, this would be our rate, but it's as a decimal. So if I ask, what would it be as a percentage, you should be able to figure that out. It would be like, oh, you just multiply this by 100, or you can just use a trick of moving that over twice. So that's your rate, but as a percent, we would say r is about 9.2%. So that's what Bruce would be looking for, to at least have the 9.2% to grow, triple his money in 12 and a half years. All right, we have 2 left, and the rest are for you to try. Just another basic one of solving it, which we already did with some word problems, so this should be even easier. So solve the following equation for the indicated variable. Okay, so we're going to get rid of the exponent. We're going to get rid of this number here. Okay, so let's go ahead and get rid of the 12. We're going to subtract 12 on both sides. That goes down. We get x to the negative 3 over 4 equals 125. And then to get rid of the negative 3/4, we're going to do the reciprocal power. So 4 over 3 negative. Over here, 4 over 3 negative. These go away. We're already done. We get x by itself. You can put that into the calculator. I think I'm going to do some in the table anyway. Like these ones are with a table. So put that in the calculator and see what you get. You'll probably get a decimal. I'm going to do this by hand. So I'm going to flip this around and make it 1 over 125. I'm going to do this a little bit faster. Becomes 4/3. So that would be 1 over 125 to the 4/3. 1 over 125 to the 1/3 and raised to the 4th. Just keep going here. 1 over, this would be the number 5. If you look at your table, 1/3 and 125, it reads over to 5. This is 5 to the 4th. And 5 to the 4th is, Look on the table. Fourth power would be 625. So 1 over 625. And that equals x. Let's go ahead and put it at the end here. So if you did it in the calculator and you got, well, let me do 1 over 625, 0.0016, then you did it correctly. But as a fraction, no decimal, it's 1 over 625. All right, the last one we're going to do, let me see if there's any hard ones here. Calculator, it's not too bad. Those ones might be bad. I might go over those ones there and be done. All right, example 5. Do these without a calculator. Oh, we have 125 again. Okay, so we have 125 to the negative 1/3. I would make this into a fraction and flip it around to make it 1 over 125 to the positive 1/3. That's how you figure that out. And then the 1/3 goes to both numbers, but of course, the top is going to stay 1. The bottom, look at the table. 125 to the 1/3. Here's 1/3, 125, it's 5. So this answer ends up being 1 over 5. Part B. Again, make this into a fraction over 1. Flip it around, so it's 1/4 to the 5 halves. So now it's a positive exponent. And this goes to both things, so we're going to do 1 over 4 to the 5 halves. And then use the table. So 1 over 4 to the 1/2 to the 5th. Now there's a way to kind of do both these steps at once. I don't know if you noticed, but we're going to do the 1/2 first. So let's look at the 1/2. Find 4. So the answer is 2. And then you're going to hold at that 2 and then go to the right to the 5th power. So 2 to the 5th would be 32. This is 1 over 32. Once you get better at looking at the table and figuring those out, it's not that bad. Okay, last one for this example. It's a negative 3 over 2, and it's already a fraction, so let's flip this one around. We're going to get 25 over 64. Now let's raise to the positive 3 over 2. Whoops. I would suggest trying this yourself and make sure you get the same thing as me. I'm going to look at the table now and try to figure it out without doing all these extra steps. So I know the 25 gets 3 over 2, so I need to do the 1/2 first. So 1/2, 25, read across, that's 5. And then we're raising it to the 3rd power. So 5 to the 3rd would be 125. So my top answer would be 125. Bottom, do the same thing. We're going to do 64 to the 1/2 as if we separated it. So 1/2, 64 down here. So you get 8. And then raise that to the 3rd power. That's 1, 2, 3, right? That'd be 512. 512. And if you want to check to make sure it was right in the calculator, you can actually divide 125 divided by 512. It's about 0.244. And so you can check and see if that is correct with this example that we started with, if you put that in the calculator. So the whole point is to do this without a calculator, and we're going to probably do part of a test where we don't have a calculator, and you have to do this with just using the table. So make sure you know how to use the table. Last thing I'm going to go over as like a little bonus here, I'm going to go over number 4 in the huddle. Mastery should hopefully be easy enough to do yourself. And then we'll be done. Tell whether or not the expression equals a to the negative 2 over 3 for a is greater than 0. Simplify and then write yes or no. Okay, so I'm just going to simplify these. If you were to square everything inside here, that would also square this negative. So it's like having 2 of these, right? You really have this times a negative a to the 1/3. So really what you're doing here is you're multiplying 2 negatives together just to get a positive a, and you're adding exponents. So that would be, adding the exponents would be 2 over 3. And, oh, that's not the same thing. So you're going to say no. Does not include a negative. That would be positive. All right, how about part B? The bottom here you can simplify. Pretend it's 2 over 1. So it's going to be 1 over a to the 2/3. Is that the same thing as this one? Actually, it should be. Because if we take this off to the side, a to the negative 2/3, That's one way of writing it, but you could also make this a over 1 and flip everything and make the exponent positive. So it does match. They are the same thing. This is a yes. Part C, negative raised a to the negative 1, raised to the negative 2, raised to the negative 1/3. This would actually be multiplication 3 different times. So we'll keep the a there. Negative 1, negative 2. These two together would be 2. Put over a fraction here. And we're multiplying that by negative 1/3. So go across the top and bottom. That would be negative 2 over 3. And that is the same thing. So that's a yes. Part D. The negative's in front of the a, not on the exponent. Can't do anything with this problem at all, actually. This is a no. The negative's out front, not on the exponent. Part E. Okay, we could just multiply these together. That's pretty simple. Power to a power. So we go 1 times negative 2. That would be a negative 2. And then 3 times 1 is 3. So it looks exactly the same as this. That's a yes. And the last one, 1 over a to the 2 over third power. And I don't know if you noticed, but that's the exact answer we got in part B. And when we simplify it over here, so that's obviously a yes. No work we have to do for that one. This is the same thing as, switching them around and making it a negative exponent here, negative 2/3. I think that was the only tricky one that's in the huddle / mastery. So you should be able to finish the rest of them to turn in. And now we'll finish chapter 7 to be ready for a chapter 7 test.